In this video, we are diving into one of LINQ's most intriguing methods, SelectMany. This method might seem a bit complex at first glance, but it's incredibly powerful once you get the hang of it. SelectMany is a method that enables you to flatten collections within collections, transforming them into a single, seamless sequence. Think of it like this. Imagine you have several music playlists, each containing a number of songs. Now, if you want to create a master playlist featuring every song from all these individual playlists, SelectMany is your go-to method. It simplifies the process by merging these separate collections of songs into one comprehensive playlist, ensuring you have all your favorite tunes in one place. This example illustrates the essence of SelectMany, making the complex task of combining multiple collections into one straightforward and efficient. In this video, we will go through everything you need to know about SelectMany, from its basic concept to its various overloads. So, let's get started and unravel the capabilities of this method. The SelectMany method in LINQ is a versatile tool with 4 overloads. Let's delve into these overloads, starting with the first and simplest one. The basic structure of this overload involves a lambda expression with a single parameter. This parameter represents the elements of the collection, from which we intend to extract data. To grasp how this overload functions, let's consider a practical example. Imagine we have a data table with 3 columns. The content of the third column is a string, but it's composed of various values separated by commas. Suppose our goal is to retrieve all values from this third column, with the desired result being an array of strings. Here's how we can achieve this using the SelectMany method. Initially, we define the source data, which is the data table we want to query. We employ the SelectMany method, accompanied by a lambda expression. In this step, we split the contents of the third column by commas. This operation results in a collection containing all values from that column. If needed, the select method follows. It's used here to trim these values, ensuring we remove any extraneous whitespace. The resulting collection is thus a cleaner version of our initial data. Note that if trimming isn't necessary, you can skip the select method. Finally, the toArray method is used to convert the collection into an array. This results in an array of strings, effectively gathering different values into a single collection. This approach demonstrates how SelectMany can be utilized to collect and consolidate diverse values into a unified collection. It's particularly useful for handling data structures, where elements need to be extracted, transformed, or flattened from complex collections. Let's explore another example. Suppose we have a table that includes some duplicate rows, with the first column serving as the primary key. Our goal is to create a new table containing only the duplicate rows. Here's how we can achieve this using the SelectMany method. We start by specifying the table we want to query, 𝗫𝗫𝗄. Next, we group the rows by the value in the first column, which is the primary key of the table. This results in the following groups, where each group contains rows with the same value in the first column. Using the 𝗬𝗃 clause, we filter these groups to retain only those containing more than one row. This step ensures that we have groups where each contains at least 2 similar rows, indicating duplicates. In other words, this condition is to get only the duplicate rows. We then use the select method to choose these groups. The SelectMany method is applied to flatten these groups into a single collection. This step transforms our grouped rows into a single, continuous sequence. The resulting collection, which is of type 𝗖𝗵𝗽𝗀𝗪, is then converted into a data table using the copy to DataTable method. This approach yields a data table that includes only the duplicate rows. Without SelectMany, the result would be a collection of groups, each containing different rows. It's also possible to achieve the same outcome without using SelectMany. The alternative query is structured as follows. After grouping and filtering for duplicates as before, we add a new from clause to iterate over the elements, data rows, within each group. We then select each data row from these groups. This approach essentially replicates the functionality of SelectMany, flattening the groups into a single sequence of rows. Now, you might wonder, why use SelectMany if we can achieve the same result with from and select? The answer lies in the syntax you choose for your LINQ query. Here's how it breaks down. To write a LINQ query, we have 3 different ways. Query syntax. It's all about clauses. Ideal for those who prefer a declarative SQL-like style. Here, you would use from and select for tasks like flattening collections. Method syntax. This is where methods shine. If you prefer a more functional programming approach or enjoy the concise nature of method chains, SelectMany is your tool for flattening. Mixed syntax. As the name suggests, this blends both methods and clauses. Depending on your preference or the specific requirement of your query, you can choose between SelectMany or from and select. In essence, whether you choose SelectMany or from select, depends on the syntax style of your LINQ query, and your personal or project-specific coding preferences. Both approaches are powerful in processing and manipulating data, especially when dealing with complex data structures. Let's explore another example of using SelectMany or from select. I have the following XML file, which contains different book elements, where each book element contains different child elements. Suppose I want to retrieve the values of all addition elements under additions element. Here's the query to do that. I used SelectMany to select all addition elements. As you can see, some book elements contain more than one addition element, therefore I have to use SelectMany method. After that I use select method to retrieve the value of each element. At the end I use toArray method, to convert the output to array of strings. The result will be the following string array, which contains all values of the child elements. This query is written in method syntax with SelectMany method. Let's write the same query using mixed syntax. Here I used from and select instead of SelectMany method. In the second from clause I am retrieving the addition elements. And using select clause I am selecting the values of each element. The result will be exact the same array. This is how to use the first overload of SelectMany method. Let's move on to the second overload, which has the following structure. The structure is exact the same such as the first overload. We only have one parameter more here, which represents the index of elements. It's like the second overload of select and where methods, where we also have an index parameter. This overload can be used in case the position of the elements is important. I think the overload is clear and there is no need to explain it. Let's move on to the third overload of SelectMany method. This is the structure of the third overload, which is similar to the first overload. We have two lambda expressions. The first one is exact the same such as the first overload. This projects each element of the original source collection into a new collection. The second lambda expression defines how to transform each element from the original source collection and each element from the associated new collection into a final result. To understand it better, let's consider the following example. I have the same XML string again and I want to get the values of the addition elements. But now I want to have the book title with the addition value as one string. Here's the query to do that using the third overload. SelectMany method has two lambda expressions. The first expression is to project each book element into a collection of child elements, specifically the addition elements within that book. The result of the first lambda expression is the following collection. The first two values are from the first book element, and the third value is from the second book element. Now, the second lambda expression. Here I have two parameters. Book still represents each element from the source sequence. It's the same book element being processed in the first lambda expression. The addition parameter represents each element from the collection produced by the first lambda expression for the current book. In other words, for each book, this lambda expression iterates over all of its addition elements. The purpose of this second lambda expression is to result in a final transformed value, which is a string that combines the title of the book with the value of the addition. At the end I use toArray method, to convert the collection to array of strings. So, the result of the query will be the following array. As you can see, each item consists of the title of the book and the addition value. I can also do the same without using SelectMany method. Here's the query in mixed syntax. I added a second from clause to loop the addition elements. Using select I am defining how the data should be projected. Here I have the same statement what I used in SelectMany method. The result will be exact the same array of strings. Let's delve into another example involving data tables. Consider we have a data table with various products listed in the second column, each belonging to a category specified in the first column. Our objective is to create an array of strings, where each string combines a category from the first column with a product from the second column. For instance, the first item might be electronics TV. To achieve this, we will utilize the third overload of the SelectMany method in this way. The purpose of the first lambda expression of SelectMany method is to select the different product values from the products column. It transforms each row's product list into a collection of individual product strings. This results in an array of strings, where each value from the second column is an individual item. The second lambda expression is slightly more complex, as it takes two parameters. The first parameter, row, represents the data row currently being processed. It contains the category and the products. The second parameter, product, represents each individual product derived from the first lambda expression. Here, we combine the category, from row, with each product, resulting in a new collection where each item is a formatted string combining the category and product name. Lastly, we convert this collection into an array of strings using the toArray method. This results in an array where each element is a string formatted as category product. Through these steps, using the SelectMany method, we efficiently transform and flatten our data table's data into a desired structured array. We can also use mixed syntax to achieve the same without using SelectMany method. The query will be as following. So, we do exact the same but without SelectMany method. The result will be again the same array of strings. This was the third overload of SelectMany method. The fourth overload is exact the same with only one more parameter. So, the first lambda expression contains an index parameter. The overload works exact the same such as the third overload. Here we can use the index of the elements in case we need that. That's all about SelectMany method.